Hello friends, I welcome you all to our channel Let's Learn with Bharti. I am Bharti Redas. This is our first video on this channel. This video is about introduction to metabolomics. So let's start it. So let me give you a short introduction about metabolomics. What is metabolomics? Metabolomics is a relatively new field of research and the youngest of the triad of system biology that is a part of alongside genomics, proteomics, also transcriptomics. And here's a history about metabolomics. What is metabolomics and history? The term metabolome was first introduced in 1998 and even up to 2010, metabolomics was regarded as an emerging field. In the late 1940s, Rogers Williams suggested that each individual may have a metabolic profile that was reflected in their biological fluids. He demonstrated his theory with paper chromatography to stabilize pattern in the metabolic components of bodily fluids such as urine and saliva of patient schizophrenia. Here's the definition and background about metabolomics. And a simple line about metabolomics is that metabolomics is a study of metabolites, and metabolomics is a scientific study of chemical processes involving metabolites and small molecule substrates, intermediate and product of cell metabolism specially. Metabolomics is a systematic study of the unique chemical fingerprints that specific cellular processes leaving behind, the study of their small molecule metabolite profile. Genomic provide an overview of complete set of genetic instructions provided by the DNA, while transcriptomics look into gene expression patterns. Proteomics study dynamic proteins, products, and their interactions, while metabolomics is also an intermediate step in understanding organisms' entire metabolisms. If we study metabolites, first question came into our mind is what is metabolite? So this slide describe about metabolites, and a definition about metabolite is that any organic molecule detectable in the body with a molecular weight is less than 1500 Dalton is called metabolites. And this picture is also describing about some sort of all omics family, and metabolites includes peptides, oligonucleotides, sugar, nucleoside, organic acid, ketones, aldehydes, amino acids, lipids, steroid, alkaloid, food additives, toxins, pollutants, drugs, and drug metabolites. Here are some factors that influencing the metabolomes, which is age, gender, muscle to fat ratio, amount of physical activity, and hormone functions. If we study something, we have to know about their importance also. So here's the important fact about metabolomics is that it will help us to identify diseases. Less than 95% of all diagnostic clinical assays test for small molecules. 89% of known drugs are small molecules. 50% of all drugs are derived from pre-existing metabolites, and 30% of identified genetic disorders involve disease of a small molecule metabolisms. Small molecule serves as cofactor and signaling molecules to thousands of proteins. Here are some detection techniques: mass spectrometry, nuclear magnetic resonance, qualitative and quantitative assessment, ion mobility spectrometry, electrochemical detection coupled to HPLC. Here's the metabolomic applications: toxicology testing, clinical trial testing, fermentation monitoring, food and beverages test, nutraceutical analysis, petrochemical analysis, genetical disease test, nutritional analysis, etc.